Algebra 2A, Unit 5, review for assessment, the last final portion. Here we go. So let's do this. We just take the base, the little 2, the base. He swings to the other side. We wind up with a 2, the 4, and the x. They don't move. It's just that middle guy. And now the question is, hey, what 2 raised to what power would give me a 4? Anybody know 2 raised to what power would give 4? Yeah, 2. He raised his finger 2. So some of them are easy when they're in the right position. Now, I don't know if this is an A, B, or a C. That's too bad that the answer looks like part of the question. Somebody might be confused, like, oh, you just take the 2 and make... No, you don't just do that. You ask that question. Let me do it again over here, down here with the 16. There are 4 questions on the test where they don't put an equals. They just have this left side and no right side. It is your job to know that if there's no right side, the question is, hey, what does all this stuff equal? What does all this stuff equal? In other words, we don't know what it equals, so it equals something, question mark. It equals something, x. We don't know what it equals. But by putting that extra part, you're able to do the, whatever's at the bottom, swings over. And now, we are left with the base 2 raised to a power of x. And then, I guess we'll keep this 1 over 16. So you almost want an x to be over there. Because when it is, when you move the base over, you're guessing with your calculators or whatever, and you're saying the question, hey, 2 raised to what power is a 1 over 16? Send those back, please. X raised to what power is a 1 over 16? Here comes the question. X raised to what power is a 1 over 16? Anybody know? And this is a guess you can't put in the calculator to see what might spit that out. Oh, the calculator may not write it out this way. Anybody know? Let's look at A. 2 goes over here. So now we have 2 raised to the what power? We don't know. It's a question mark. She's saying no. I'm going to go in there. But let's let it go. You don't have to win. You just have to... All right. Get on with her. Go ahead. Someone take a look at that first one. Don't.
5.
Yeah, 5. You put it in equal 5. That is, if you know what this side equals, you put 2 to the power equals that thing. So down here, you need to find out what this thing equals, so that you can start putting in 2 to the power to get to that thing. Someone can calculate, do 1 divided by 16 for me, please. We'll just do it together.
Is that to -4?
It is. No. Is it? Yeah, because 3 is 8. So x equals -4 is going to be correct. Let's take them through to get them to where you got. What does 1 over 16 equal?
0.0625.
0.0625 is what the left side equals. Your task is to figure out, hey, what can I put in on the power of 2 so that I can get this 0.062? Now you always start with regular numbers, 1, 2, 3, 4, 5. See what the pattern does. Oh, it keeps getting bigger and bigger. Okay, that's not it. Then you start backing off, but maybe 0. Well, you know that 0, anything to the 0 power is going to equal 1. Well, hopefully, if I haven't told you the math teacher, I apologize. This number is less than 1. You know, it's 6 cents. So somebody need to make this number less than 1. How do you make something less than 1? You turn it into a fraction. Fraction by definition means, hey, I'm less than 1. If I were 1, I'd be 1. If I were 2, I'd be 2. But if I chop the candy in half, it automatically turns into a fraction 1/2 and so on. So you know you need to turn, or whatever. He said the answer was a -4. Did you try -2, or what other things did you try? Do problem E. All right, I'm going to just do D, E, and H. You can imagine, oh yeah, I'd have been able to do that. Or you can lose, right now you're losing the privilege of discovery. Like, would I know how to do it before he told me? Tick, 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 where are you? I'm just going to go E first. Oh shoot, E is so sweet. Calculator. If I can swing that 2, I wind up with 2 raised to some power. What is 2 going to be raised to? Pause. When you raise something to the 1/2 power, essentially what you're doing is you are writing a different version of taking the square root of that something. And so here comes 4 to the 1/2 power. Yeah, I'm not going to make it, dang it. I don't even mess around and tell them stories. Yeah, granted, I stopped for half a second to mention the texting thing. That didn't take that long. Anybody know the square root? Oh, woohoo! Anybody know what 4 raised to the 1/2 power equals? Can you believe this? People out there, they don't even know it. If you're here watching this video, and that means 2 of you, the people sitting out here, and I already like told them stuff, but they don't want to. All right. Did someone say the answer and I just didn't hear it? Okay, that's a little bit too much. You gave the right answer. Did you say it?
No,
Who said it?
I don't know.
You heard it over there?
Yeah.
I mean, I heard it right now, but is this the first time you said that or the second time? I like what you're saying. I know you said 2. I'm just saying, you just say 2 right now for the first time, or did you say before I did my little speech thing? Sweet, that means no. The next time they write down what is the square root of 4, the square root of something, you rewrite it. Rewrite it as 4 to the 1/2 power. Yeah. Next time I say, what's the square root of 64? You say, Professor, excuse me, on that question, square root of 64, do you mean what's 64 raised to the 1/2 power? Teacher first was like, the first I no, I said to the square root, but then they go, whoa, you're a student, did you just say raised to the 1/2 power? Hey, how did you know that? Now you can have 2 choices, you can go like, my teacher told me, but back off of that one, that'll be your second answer. You just said, I know things. Yeah, I'm like a genius, and sometimes I don't like to show it. Yeah, but this moment I do want to show it. Any other question that you've been wondering about? Because I can answer it right now. Teacher's not going to ask you, but if they do, when they ask you the question, you say, I just don't feel like asking that right now. Yeah. All right, in any case, let's do some stuff. All right, here comes the answer. I'll put it in red so it stands out. 1.4 to you. 1.4 to you. You know, I wonder how they expect you to get that answer, because I think when they offered these, it wasn't a calculator type of problem. It was just a by hand thing. Make sure you save them in that order. Go from there. All right, video people. I'm doing a cartwheel right now. It hurts. Press it. By just looking at letter E without doing any writing, can you say what the answer is? Don't say it yet. Don't say it yet, so other people have a chance. Let's get it 5 seconds. You're supposed to have your test right now. You're going to have 30 minutes. Make sure you come past on Wednesday. Sorry. Do this. What is the answer to E without doing any work?
8.
Hopefully some of you said it to each other. What you got to be able to see is a log problem says this bottom thing raised to this power over here equals what? It's like a little circle of life. My mom just went to see The Lion King for like $98, but I'm going to help pay for the ticket. I'm doing 1/3, so I'm going to send out $33. And my brother and my sister, they can do it the other thirds. I'm going to have to ask her, did she like it? I've seen it. I've seen it twice. It's a great play. If you ever seen Lion King in the theater, it's amazing. Because you've seen the cartoon, but how are they going to do the cartoon thing in real life? Oh, it's amazing. You should see it. Here it goes. So again, 2 raised to the 3rd power equals what? It equals 8. If you need to see it, here it comes. That's one reason you should go to college. I mean, you don't need to go to college to go to the Lion King, but to have the money to spend to go there and feel okay that you spent $90 to go see a play, those people go to college. It's part of the game. It's part of the thing. And again, you don't have to go to college, but why not? It's a big party. 8 equals 2 to the 3rd power. Am I still on this thing? This is from before. Let me see. I got 2 more. Don't talk to them. Don't talk to them. I'm going to do D and H. I'm erasing. I want to talk to you. I just met somebody this weekend, but I'm not going to talk to you. I did juggling lessons at my son's school, but I'm not going to talk to you. This guy knew me. I didn't know him. Technically, I guess it makes me famous. Um, let's see. All right. D and E. Let's do H first. H because it's the easy kind. If you just came in, you need to write these 4 problems on the board. It's going to be like to the 0 power. What does he mean? It's going to be to the 0 power. Get rid of the log by swinging it over to that side. That means that 2 raised to the 0 power equals what? Anybody know what 2 to the 0 power equals? I heard it. And I do appreciate you guys speaking lower that way. If it's not right, we can take it back. Say the answer again, please.
1.
1 is correct. 2 to the 0 power equals 1. Anything to the 0 power equals 1. There's some reason for it. Wait a second, something's not right the way I wrote that. Let me write y. Let me write the... Let me do it that way. We do want to try some. If you want to watch, you can watch too. Hope we get the rhythm of this thing. Logs are difficult because they're a strange language, but once you know what you're trying to do, at least setting it up, the setup is easy. That's no good. Oh, something missing. It's a question mark. Log is one of those things that allows you to seem like you're a smart person when you're 2 raised to the 1 power equals 2. I heard a 0. 2 raised to the 0 power is 1 because anything raised to the 0 power is 1.
Negative 1?
Negative 1, that's a good answer. 2 raised to the negative 1 power. Well, anytime you see a negative, that just means you have a fraction. Where the bottom number is what you start with originally, it's all over 1. The exponent turns into a positive 1. Or a positive version of whatever it was. 1, good answer.
I said what?
You said what?
Yeah.
What is a good answer too? And, it is a trick question, unless you were here in the first 5 minutes, in which case I gave you the answer already.
We just stay the same, right?
Wouldn't say the same. I'd say something like no solution or no answer. I'll put no solution. Hey, welcome back. Hey, am I recording there?
Yeah.
I wasn't nervous. All right, here we go. So we're no solution. No solution. Dang. No solution. That is, it's impossible to raise anything to a power and get 0, I guess, except for 0 raised to a power. 0 raised to anything is 0, so I guess other than 0, anything raised to the power is a no solution. Can someone tell me what number comes between 7 and 9? 8, very good. Someone different. What number comes between 10 and 11? No, 10 and 12. And no. 12 and 15. Say it again. 13 comes between 12 and 15. That's a good answer. That's one of them. Anybody know the other one? 14. Good. You know this song. All the songs I do not like this song. I don't like it. I don't know why. I know the guy worked hard on it. It's a famous song. I do not like that song. I do like this one though. All right, let's make it a little bit easy. Oh, what was the other number between 12 and 15? 14. All right, let's widen it up. Between 10 and 20. Someone who has an answer, what's the number between 10 and 20? Is it 15? Will do. So that everyone can answer. So if you've answered, don't answer. Between 10 and 20? You got to say a number out loud so we're going. I'll hold us till the end of class. You've answered before, yeah.
Oh, so no percent.
Right, Philly. We're just going to hold them out, wait them out. Yeah. 13, good. Anybody else has an answer? 10, 20, good. The guy have a good memory, say it. That'll do. Is that all of us? Or are there 2 of us who didn't? Right now I have Sergio and Randall, but maybe they answer, yeah? All right, Sergio? Oh, I mean in this group, but that's fine. I'll take it. All right, basically you're going to be asked a question similar to that. You just have to know how to answer it. So let's see if we can get this for you real fast. These 2 questions here at the bottom, the 95 and the 900, are going to be the same types of questions. The others do it. Wait a second. Oh, I see. They put it both. All right, so they did good. I get to write on both of them. But here's what we're going to do. Above here, we're going to write stuff that doesn't apply to here, but it applies to the thing that you need. It goes like this. Let's see if some people can say this. Give them a pattern. Log. Let's give them a little pattern to work with. Do it in blue. Or not. Log. A little bit higher. A little bit of a pattern. Hey, log. Pattern should be there by now. Here it comes. Yeah. Hey, anybody know what the log of 10 is? All right, I'll go to the second one. Anybody know the log of 100? Oh, just for the record, this means I'm a bad teacher, just so you know. Whatever, here it comes. Log of 1,000.
3.
Hey, good answer. How'd you know that one? Very nice. Makes you feel all warm, toasty inside clearly. Unless you're drinking.
No.
Just checking. You just don't know how it happened? Which is cool. You could be singing genius like, I just see stuff. I don't know where it comes from. I see it and I say it, right? You hear the laughter, people? You should have come to class. It is cool. Let's see if I can do it in red. Let's see if we can help out. But you can't answer the next one. Someone else? Say it again? Yeah. She can read my mind. So like all the time, my head. Here it goes. She was it. How can we even laugh in math class? Yeah. It's not even necessary. That's why he's reading like a novel, he's drawing pictures. I like his style. Call me when you get the answer. I like that. No, he's multitasking. At church, sometimes the sermon is long, so I think I take some stuff to draw. If there's an interesting part, okay, I might stop. Otherwise, I'm going to read a book. He doesn't know the pastor is way up front. Oh, trick question. But now we don't even need a trick, we just need a pattern. As someone who hasn't answered, hey, what's the log of 1?
0.
Yeah, 0 is correct. You can see the pattern that way. You can also know that the number of zeros that you have in the number, these are all powers of 10. Why are they powers of 10? Because when you see a log and it doesn't have a number there, automatically there's a green 10 here. And this green 10 does the following. Loop it up. Yeah, loop it up. What does that equal? You got this red 1. Let me do it. Let me do the 2 reds. Red. Anybody know the song Red Wine by UB40? Red Wine. I wanted to say that, red wine, but I figured they probably don't know it. Why waste my pearls on, what was the saying, pearl before swine? In other words, if people don't appreciate you, they'll keep trying to get that person to like you. When there are 2 other people who like you, who maybe don't look quite the same as that one that you're interested in, you're casting your pearls before swine. Here it comes. So you got a 10 to the 0 power, 10 to the 1 power, 10 to the 2 power. Logs are really all about exponents, which I haven't really highlighted. And the rule simply says this. Yeah, the log base 10 of 1 has to be 0. In other words, 0 is the exponent that would get me the 1 if I raise 10 to that power. 1 is the exponent that would get me a 10 if I raise 10 to that power. 2 is the exponent, it's the answer, it's the power that would get me a 100 if I raise a 10 to that power. That's what logs are all about. Hey, what is the power if I raise whatever the base is? In the case, I have to be 10. All right, you're going to need these numbers. Did I do 1,000? Yeah, good. That'll give me the answer. Good. So here it comes. Hey, Tom, so how's that going to help me down here on problem this and this? The rule is simply this. The question is, log 95 is between which 2 famous logs? These are famous logs. By the way, please don't write that base 10. You'll embarrass me. Don't do that. You go to another class, teacher always wrote base 10. No. we write it this way without that. That's like writing x to the 1 power. That's like putting a radical sign with a 2 in front of it. We don't write those things. And if they think your teacher taught you that, yeah, I'll be a mistake. Oh, shoot, 3 minutes. Please come on Wednesday. All right, so here's the deal. Here are your 4 choices for what you're going to put on either side of the problem. Which ones do you choose? Well, if I gave you the number 12, the numbers you have to put on either side of 12 are the next smallest one and the next largest one, an 11 and a 13. If I give you the number 20, you put a 19 and a 21, the next 2 that are beside it. Well, here, let me ask on the log side, on the blue stuff. I need a blue U. What are the 2 guys? This side of the room you do the left, that side of the room you do the right, and then you get that one by yourself. What on this side of the room? What log, which of the blues am I putting to the left of log 95? Let's see, 10. Yeah. Good. Log 10. That side of the room, what do we put on the other side of it?
100.
Yeah. So you only have these 4 choices. And if they made the number bigger, you'd add another one to go with it. Log 100. Do me a favor on your paper, put the 2 partners on the log 900. On Jasmine's side of the room, the Jasmines.
On the left side?
On this guy over here. The right-hand side. Same side you got to last time. Say it again.
Log 1000.
And this side, someone who hasn't answered on that last question, so not Nadia. What do we put on the left-hand side?
Log 100.
Oh, yeah, it's log 100. Yeah. You only have 4 choices. Now, here's how they're going to ask it on the assessment. They actually want the actual whole number. It's between what 2 regular numbers? So you might be like, well, what do you mean regular numbers? The red numbers. Like, what does log 100 equal? What does log 1000 equal? They actually want to, so below the blue, put down the red. In other words, log 95, someone came up to you on the street with a gun, like, hey, fool, what's log 95 between? What? You tell me how old. You're like, is it between log 10? No! It's not between that. It's between, then you give the actual numbers. What's the answer to log 10? The whole number, the regular number, what's log 10 equal? And what does log 100 equal? Basically, the log of base 10 is, hey, how many zeros? How many zeros do you see? So when you're reading it, don't think like log it, like, whoa. Hey, how many zeros are behind a 10? Oh, 1. How many zeros behind 100? Oh, 2. So technically, the way you write the final answer is log 95 is between 1 and a 2. How about write down the answer for the log 1000 stuff? What does log 100 equal?
2.
Thanks. Log 1000? Alright. I'm on, you may have a question. You may have a comment. If I'm drawing the picture of the parent function for this guy, let me write some things down. We choose different x's. Let's do a 1, 2, 3, 4. Let's make one of them a let's make it to the 0 power, because you know what 10 to the 0 power is equals. Let's make it a 1 power, a 2 power. And then over here, just to mess with them, we'll do something in blue up there. Anybody know what 10 to the 0 power equals?
1.
Thank you. Always when anything to the 0 power equals 1. 10 to the 1 power? Let me say this. 10 to the 1 power? 10 to the second power?
100.
For base 10, to know what the answer is, the exponent tells you how many zeros will follow the 1 in the answer. So 10 to the 1 power, oh, there's 1 0. 10 to the 2 power, oh, there are 2 zeros. 10 to the 0 power, oh, there are no zeros. And then 10 to the negative 1 power. Dang, he went decimal. I'm impressed by that. I'm going to do fraction because decimal, that's intense. The negative exponent tells you automatically there's going to be a fraction. What's going to be on the bottom of it? The original thing, just with positive numbers, and always a 1 on the top. That 1 on the top, oh, you got the calculator? Oh, I'm about to say, like, what you did the point 1 in your head? You did the point 1? Dude, why you had options? But I'll talk to you later. All right, so here's the deal. These are our choices if we were plotting it. I'm not going to plot it. There's only one number I'm going to make you memorize, and that's to the 0 power. Put this star here. No. Oh, I put them wrong. It should be a 1. Zero 1 is the one I want you to know. Because no matter what the picture is, no matter what the base, like it's a 10, it's 11, it's a 14, it's a 3, it's a 2, the base doesn't matter. The minute that 0 is the exponent, 0 is the y line, it's always going to be anything to 0 power equals a 1, and as a result, when you are drawing the parent function for y equals 10 to the x called an exponential function, it's exponential because like that balloon, x is floating up in the air, and you need a log to bring it down. It goes like this. There's going to be a dot at 0, 1. No matter if this is a 10, a 3, a 14, a 25, 1,000, a million, it doesn't matter. At that number raised to the 0 power, it's always going to be a 1. This is going to be hard to draw. The rest of it is going to be like an airplane taking off from the ground. The x-axis is the landing thing. I used to go to LAX and watch airplanes take off and land, and there's one spot you be in where the airplane has to come like right down, like right over you, but it's about to land, so it's like, "Whoa!" And I think I threw like a rock up, which is a bad idea. And then I think I'm taking my son, then he take him back before they get too old, because you stand right there on the street is Century and it's La Cienega and Century. Like right there, the planes have to land, and you stand right here, and here they come like, wow, dude! Or you can go sit off of Imperial. There's like a bench seating where you can sit here. You can watch airplanes land and take off or whatever. And it's LAX, so it's kind of cool. You're a little bit further away, but the other one you're like right over it. So you can take the kids there sometime soon. Yeah. In any case, landing airplane. Basically, the picture is of an airplane taking off. The airplane starts on the strip, but it never touches the ground. This x-axis is going to be an asymptote. It's a line that you come close to, but you never touch. I'm sure, and here I must have done the club asymptote thing. Have we done that in here? Little strobe lights and me dancing or whatever. And second semester, we have to talk about asymptotes again. I don't have the time to do it now, but it's clearly a memory you want to have. Anytime a teacher has like club music and the lights going on and off, and he's the he and he's dancing like the she, and then all that for the word asymptote. Oh, you gotta love that. Let's do this. Do a green dotted line. You can do it. That's the picture for any exponential function. If this 10 were a 17, same picture. Was it a 100, same picture. 25, same picture. This is your parent function. That green dot, and let's write down that y-intercept. Let's write that y-intercept 0, 1. Doesn't look very good. That's the point that you're going to move around when they have you move it up, down, left, right. And the rest you just kind of draw kind of a line through it. Can I write that again? 0, 1. Let me do, sure. I don't know which kind they're putting on the test, so I'll do a doubler. I'll do a singular, 2 singulars, left, right, up. I'm going to do this guy, and then you're going to try and do this guy. Here it comes. We'll flip to the back, we'll do the same thing all over again. Here it comes. Hey Thomas, move this picture forward to the left and write out the equation. Oh shoot, okay, so here's the equation, parent function. Let me write down the equation to begin with. Y equals 10 to the x, and then I'm going to add stuff. His part over here, y equals 10 to the x. That's the equation for the exponential function. What are we going to do with that, Thomas? First, let's move the picture around, then write the equation how we did it. Tick, 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 tick. 4 to the left. In other words, find that original green dot and move it, because he always has to be in the same spot. Move him 4 to the left. 1, 2, 3, 4. I'm going to blue dot the new thing. Now I do my airplane and I'm done. Now the airplane is still on the runway, then move it up or down, so the dotted green line still is there. That's your asymptote. That line is when will x equals 0, like or rather one where y equals 0. Y will never equal 0. The answer can't be 0. So let me draw my picture. Red line flying, red line flying. Flying, I'm dying. Look at it, see if you're okay with it. Move to the left. You can try to move it up 6, the original. Oh, I probably should put the original picture there. I'll put the original picture in. Can I undo? Can't undo, so I'll make this new picture, sorry, in blue. And let me put the original picture so you see what the original looked like. Original's in red, the new one's in blue. Hopefully it doesn't mess you up. Do the original thing over here. If you want to try and do it without looking to see if you get yours right, you can. Put in the original so that we can tell that you know what you're doing. The blue will be the new stuff. Hey, Thomas, move it up 6. I can count. Here it goes. 1, 2, 3, 4, 5, 6. That new line below the 6 is always one below the dot. One below the dot is the asymptote. Hopefully they can see that. One below the dot. How does he know it's one below the dot? Because on the original, there's one below the dot. Yeah, hope they can see it. If not, too much information. I don't know why I thought it'd be, oh, just give them a little bit and they just start the test. It's like a whole class period. And I haven't told that many stories. No. No, I haven't. All right, your task is to try to do this one. See if you can do this one. Oh, I haven't even written in the form. They write in the form that take your hand. Someone tell me what to write for the formula for, what am I going to add to the first one? We moved it left or right. It's tricky. There's a parenthesis involved. Yeah. Now tell me where to put that adding.
Yep. Do you include the x though, like in the parentheses?
Going to be in a parenthesis.
10, I mean. Okay, so we parentheses 10 minus, no?
You have the right idea though. Somebody want to help her out? You have the right idea though. 10 won't be involved though.
So just the x?
Mm-hmm.
Oh, you put the parentheses over the x.
Mm-hmm. All right, so you sit to the right, to left. Yeah. So there it is. So remember, left and right is always the x in a parenthesis with a number. Up or down is just the original whole thing with a plus or minus at the very end. Someone different, say what we're going to put on this one here. We moved it up 6. And he's at the very end. If you write it wrong, it can look like that plus 4 is, that plus 6 is up there with the 4. Or rather, it's up there with the x. But it really is, I had all this black stuff and I just added on. Laugh at that. Alright, so take a look at it, see how you feel about it. Alright, try and do this one. This is the time they're going to give you, I think they're going to have a doubler on it. I'm not going to do like a single thing or whatever. If I run the equation for this one here of the asymptote, it would be, where is the dotted line? Where does the dotted line hit the y-axis? Oh, it hits it at 5. It hits the y-axis at 5. That's how you write the equation for a horizontal line. Like, okay, horizontal line, where I know you're going all this way, but where do you hit the y line? And that's how you write the thing. Anybody know the equation for the x-axis? Where does the x-axis hit the y line? At y equals something. That's cool. I feel like you guys are learning a lot because you don't know stuff. Y'all don't. All right, let's see. Let me answer this one. We'll do a couple back. I'll show you your test, and now thank you for coming. All right, if I were doing it, well, let's start with the equation. Y equals 10 to the x. Can someone tell me the first piece, and someone else can tell me the second piece as to what we're going to write in this equation? X minus 3, and what do we need with that? Thank you. Without the parentheses, I feel you could argue the thing, and as a teacher I probably wouldn't fight you, but for now I'm going to mark you wrong if you don't, but I think you could argue it, because if it's floating up here, x minus 3 is x minus 3. Someone say the other part, please?
Minus 5.
And then minus 5 is down low for the whole thing. All right, hopefully they drew the picture. I don't really have time to say whatever. I'm going to do this. We'll do 3 of these on the other side. You can choose the 3 on the other side. I got to tell you what the original looks like. The original looks like it's flying up high. It's going to fly up high like like it was flipped over the diagonal line, also called y equals x. That's the equation, and then it'll be a weird airplane flying out of it'll be like if you saw the Lego movie. No, that wasn't that. But when Chewie got eaten up by that thing, if they were flying out of his mouth, that's what the second picture is gonna look like. Hit the hyperdrive, Chewie. All right, here goes. This guy here, the original is Doc. Did I tell you guys I'm not gonna see the Star Wars movie when it comes out? Did I tell you guys that? Because of my son. Okay, whatever. All right, here it comes. Hey, anybody know how long it takes to get to DVD Netflix? Dang it, like 6 months?
I would say 6 months.
Yeah, because it's Star Wars, so they can milk it for all the money. But I'm going to have just people tell me the story. All right, just tell me what happened. Does the black guy win? No, he gets killed. Of course he doesn't get killed. It's the first of a trilogy. He has to make it to the third one, like Anakin. So he is going to come close. And I haven't seen it. You know, they're not leaking anything. It's just, you know, patterns. I'm a math guy, so we know they can't kill him. That's like, does the girl in Mockingjay get killed? Oh, I don't know. We need to make 6 of those movies. Maybe not. This last one, though, she could get hurt. Because it's the end, they can let her get hurt, but I don't think they will. That Peter guy, they're probably going to fall in love or something like they're like about to kiss or something, so maybe it's the final thing. So, anybody going to watch the last one of those? What was it called? Hunger Games? Last one. All right. What? And then pass out your test too, so you can look at it. You're not going to be able to write, and you can decide whether you are able to come back or not. I need to go to the right 3 and up 5 units. Richard Aguilar made this, which is really a good thing, because what I used to do without it was like, apologize to the students. Here we go. Do what color? Blue. I'm going to go up, right? 1, 2, 3, 1, 2, 3, 4, 5, dot. Asymptote always one lower. No stories I'm telling about the church. Look at that. I'm stinking genius. You see me?
It goes down.
Dang it. I'm recording. Down 5 units. I give you half points if you win. If you just read it, you're all like, woo, I'm a genius. Whatever. Don't wait till you're done. Nonetheless, down 5. I can still do down 5. 1, 2, 3, 4, 5. The asymptote is 1 lower than that key point. Stinking genius twice. All right, put you in.
So where the point's at, that's where we start counting. We don't start from like.
No, yeah, you start from where the point is, because it's saying from wherever you were. Here's the new place you're going to be. All right. So I made a mistake there. Let's erase the top part. Sorry, algebras. I won't submit this one as my tape. You can do them. I got to give you the original picture so you know what to look like. To the left, sure, why not? Up, sure, why not? Then they do the 6th one here. Sure, why not? There are your 3. All you need is the original picture. Now here's the original picture. The same way that other guy always went through the point 0, 1. This new guy automatically goes through the point 1, 0. The numbers flip. So 1, 0. It has to go through that point. And the asymptote was the x-axis. Here now, the asymptote is the y-axis, 1 to the left of, which if you understand what inverses were, they're inverses of each other, and so that's why they look that way. Here comes the original picture. Up, da, 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 da. Yeah. So there's your picture. All right, Thomas, I'm just going to do these 3 so they can see their tests. Try and keep them if you want. We're recording. You can watch it. 38 minutes. Who's watching a 40-minute video of me? You don't get to see the people. All right, at least you can fast forward it. So here we go. Or just go just to the section that you need to review. To the left 2. So draw the original. Go. Original. Asymptote. I should write that word, asymptote. Asymptote. They need the equation down here. Let's put down our equation. Let's see, y equals log x. Remember to move left to right. Put the x in parentheses with this partner. Log x. If it goes up or down, put a plus or minus thing at the very end. Y equals log x. You always start with the what's the one looking for with the parent, and then you get the kids. Here it comes. The original. You go this way. What do you want me to do? Move it 2 to the left. I can do that. 2 2 to the left. 1, 2. Asymptote is going to be 1 to the left no matter what. In blue. In blue? Sure, why not in blue? New picture in blue too? I'm making green. In blue. This is bad. Everybody in blue is no good. The blue is the new. I would ask you, well, someone might say it fast. You say it in 5 seconds and I'll take your answer, otherwise I'll just do it. The equation, what am I going to put for the equation for this one? 5, 4, 3. See? -2 is a good choice, is a better choice. +2 is opposite inside the parentheses, outside the parentheses, as you would imagine. Here we go. I need to go up 1, do the original. I can do the original. Asymptote is on the x, the dot's right there. That original dot is at 1, 0. That's your x-axis, rather your x-intercept. 1, 0. 1, 0. Do you want to go red picture here? What do I want to do? Move it up 1? Sure, I can move that green dot up 1 to here. Oh yeah, it's gonna be messy. 1 is your asymptote happens to be the same because it's still just 1 back. Somebody here like, dude, you're going too fast. Well, yeah. All right. But it's on video. Just go to minute number 41. Skip all the previews. And someone say the equation if you can. 5 seconds. 5. Plus 5 plus 1. Thank you. Because it's just going up or down. You know, let me do this. I don't think I have to, but I'm gonna do it. I'm gonna put the x in parentheses by itself. To say that, hey, no, that x and the 1 are not together. It comes after the whole thing. Maybe I could put the whole thing in parentheses, but somehow I'm going to do that. That way, you know, someone forgets parentheses, like, well, no, they're together, no, they're not, whatever. The last one, see if you can do this last one while I go get your test.
Yeah, it will be.
6 to the right and 4 down.
Okay, thank you.
1, 2. No, I need the original picture. Original picture. Click. Click, 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 click. To the right from that dot here, not from the starting point, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. Asymptote always 1 to the left of that. I'm going to make it in green. I've been making it in blue.
Oh, okay.
And then, take a look at my picture, take a look at your picture. Someone say out loud what the formula is.
-4. In parentheses, -4.
Is there a reason you chose 2?
Oh no, 6.
Yeah, see, we all make mistakes. Yeah. But this is a safe environment where it's okay to make a mistake. That's technically supposed to be with the math class. Is it plus 6? You make it where someone's willing to say their answer, and even if they're off, it's no big deal. We're going to fix it kind of thing. All right.